go rewatch these on YouTube. Let me see if someone just came. I think someone did just come. Let me add them to the vocab, or not to the vocab. That's very different. Add them to the attendance. All right. We're going to start several new topics tonight, and one of them is percents. So we've talked about pieces of things, and we've done problems with them. We've done fractions, we've done decimals, and now we're doing percents. So when we do any of these things, we're talking about pieces of something else. So if we were talking about a pizza, so say you had this pizza and there were 8 pieces, and say you ate half of it, so there are only 4 pieces remaining. 1, 2, 3, 4. So how much pizza did you eat? Well, you could say you ate 1 out of 2 or 4 out of 8. You could say you ate 0.5 of the pizza or 0.50, or you could say you ate 50% of the pizza. Those are all different ways of saying the same idea, saying you ate like part of the pizza, because you have to count by slices, not by the whole pizza, because you didn't eat the whole pizza. So those are all different ways of saying the same number, and some are more useful in some situations than others. Percents go from 0% to 100%. You can actually have percents that are negative or percents that are bigger than 100% in some special situations. But normally we're just going to do them 0 to 100%, talking about how much of something we have. Like 100% would be full, 0% would be empty. All right. Let's look at a percent problem. So there's sometimes we're going to be asked what percent of something is, or what part of something is a certain percent. That was very mathy and confusing, I know. So here's the path we can go. We can go fraction to decimal. Oh, that's not how you spell decimal. Decimal to percent. Or we can go percent to decimal to fraction. Excuse me. So when we know what fraction something is, we can say how many individual things there were, because when we're talking about fractions, we're normally talking about like pieces of pizza, or how many tacos someone ate, how many apples someone has, those kinds of things. So here's the first problem. This is a word problem. I'm going to put in, and I'll work this because this is the first time you've done this. Sorry, I don't know why they keep bolding. That's annoying. All right, in a class of 30 children, 18 of them are girls. What percentage are girls? So we can first write a fraction of the girls. We can say 18 over 30, fraction. And we want to get a percentage. So to get the percentage, we've got to do a decimal first. All right. So let's try that out. So how do we go from a fraction to a decimal? Well, we just divide it. So we say 18, we say 30. So 30 goes into 18 0 times, but does it go into 180? Let's see, 30 times 6 is 180. So it goes in 6 times. 180, 0. So the decimal of this is 0.6. Now, how do we go from a decimal to a percentage? Well, that's actually much easier. You can just go 1, 2, and then add a percent sign. So 0.60 becomes 60%. So 60% are girls. All right, let's go the other direction. So here's the next problem. What is 40% of 120? All right, so now we need to go from percent to decimal to fraction. And then once we have fraction, we can find out the actual number they're asking about. So we start off with 40%. Now to go to decimal, we just get rid of the percentage and go 1, 2. So the decimal is 0.4. Now to make 0.4 into a fraction, we're gonna have to do this 0.4, and remember that's over 1, because when you divide anything by 1, it's the same thing as saying that number. So 0.4 over 1 times 10 over 10 equals 4 over 10. And we can simplify this by dividing each top and bottom by 2.
So why did you do 10?
Yeah,
10
good
over 10?
question. So when the decimal is like this, it only has a tenths place right here. It only has a 4. So to make it be like whole numbers like this, you just need like 10. If it was 0.41, you'd need to do you need to do 100 over 100.
Oh, okay, okay.
And if it was
Understand.
like something even crazier, like let's say it was 0.4173, you'd have to do, this one would be 10,000, or 10,000 over 10,000, which is kind of crazy. But I don't think we'll be facing those, at least not in our dreams, maybe in our nightmares. And Jose, you asked why I didn't divide there. If I divided, it would like 0.4 divided by 1, that would have been a really ugly, it would have been really ugly and not neat like this one. And the whole point is we don't want it to be a decimal, we want it to be a fraction. So we get, the 49 and 120. Like, why don't I divide 40 by 120? Is that what you mean? So yeah, so when we say 40% of 120, I can't just like do something with that. One shortcut that I can do is actually I can say 120 times 0.4, and then I would get 8, 4, and then I would get 1, 2, and the answer would be 48. I don't like doing that as much because I think it's like dangerous with, you can mix decimal points up and stuff. I like doing it this way better. But that's why I didn't multiply like that. And you wouldn't divide because what you do to get that answer is it's a multiplication problem. So 2/5 times 120 over 1 is 240 over 5. So now you have to say 240, 5 pieces, 5 goes into 24, 4 times 20, and 5 goes into 48 times. So 48 is the answer. Excuse me. All right. Let's try this one. All right. I want you all, I'm going to give you a problem to try. I'm going to kind of help you set it up, but I want you all to try it, okay? Because I want, when you're coming here, you get the chance to practice and we'll talk through things. So we've got a packet of 40 Skittles and 12 are red. So what percentage of the Skittles are red? So here we have a number. Well, then we got to go to a fraction, then a decimal. Geez, that's a lot. Decimal, then finally a percent. So you've got 4 steps. You got to make it look like a put the number down, then you got to make it into fraction, then a decimal, and then the percentage. So why don't you all try on that? I'm going to give you about 2 or 3 minutes, and then I'll give it a try. But I want you all to have a chance at it. All right, we got some numbers coming in. I got some messages coming in. Good. I'll let folks keep trying. I'll give it like a minute more. All right. So are you changing your answer, Steve?
Uh, I think it might be the first one.
Okay. Yeah, because I see 2 numbers for you.
Yeah, I think it
All
was the
right.
first one.
So let's take a look at this. So first we have the number of Skittles, 12 of them. Now to make it a fraction, we got to say 12 over 40. Now we got to go to a decimal. So to do that, let me divide that out. I'm going to add a decimal and a 0. 40 goes into 123 times. Bring down a 0. It goes in 0 times, so it's 0.3. Now to go to decimal, remember, we say 0.3, and then we move the place over twice. So right here, and we add a percentage. So it's 30%. So 30% are red. All right. Let's try another one. This one's harder. Yeah, so when the number on the top is going to go inside the house, the number on the outside goes outside the house. All right, let's get this one. All right, this one's harder, but it's a very similar process. You're going to set it up as number to fraction to decimal to percent. So it's a similar one. So give this one a try. All right, not seeing answers coming in, but I'll let it, I'm gonna let it rest because I know this one's hard. So I will let it rest for a little bit. All right, I'm gonna give it another minute, then I'll work it. Oh, you want some time? Or, all right, I'll give a little more time, okay? Someone said they want more time. I'll give a little more time. Everyone, I hope, is working and seeing how they're doing. All right. I think I'm gonna work it so we don't run out of time for other problems. So the number is 325. We write as a fraction 325 over 400. Let's do the house. So when we do it like this, the 325 goes on the inside. Sorry, this one's hard. 400. Yeah. Yeah. So we got a decimal and a zero. How many times is 400 going to 3,250? I'm gonna guess it's 8 times. Yeah, it's 8. So 3,200. We'll have 50 left over, bring down a 0. 400 goes into 500 one time. 400, at least 100, bring down a 0. How many times does 400 go into 1,000? It goes in 2 times. So that's 800. Left over 200, bring down a 0. How many times does 400 go into 2,000? 5 times. And now we finally have it down to 0. All right. So our answer as a decimal, and I'm going to go back up here, is 0.8125. Now to make this into a percentage, we go 1, 2, and add the percentage. So the decimal answer is 81.25%. So that was a hard one, I know, but that was just to give you a little arithmetic practice, you know.
It wasn't hard, but I want to know, how did you move the decimal?
Mhm.
Why did you move it twice?
When did I move it the first time? Oh, why did I move it 2 places?
Yeah.
Okay, whenever you go from a decimal to percentage, you've always got to go 1, 2, always 2,
So
2
it's only
times.
just gonna be just two.
Yes, for decimals, it's only twice. When you
Okay.
go decimals to percentage, sorry.
So it's never gonna be more than two or less than
No,
two.
no, not for decimals to percentages.
Okay. Okay. That's all I want to know.
Yeah, I like it when there are like rules that like you have to follow because it's easier to remember. That's one of those. It's always 2.
Okay.
So let me work this one. Then after this, we're going to go to percent change, which is kind of a different topic with percentages. All right. In a class of 40 students, 25 students did their homework. What percentage did not do their homework? Well, number fraction, I'll call this frac to decimal. Sorry, this is just messy, to percentage. What number? Well, it's not 25 because 25 did their homework. They want to know did not do. So to say how many did not do it would be 15 because 40 minus 25 equals 15. So how can we write this as a fraction? We can write 15 over 40. To do it as a decimal, how many times does 40 go into 15? Add a decimal, 40 goes into 150, 3 times. That answer is 120. Left over 30, bring down 0, 40 goes into 300. Let's see, 40 times 7, 280. So it goes in 7 times, 280. Remainder 20, bring down a 0, 40 goes into 205 times. So our decimal is 0.375. Bring up the decimal right there. Now we do our, for the percent, we go over 2, 1, 2, add the percent. So 37.5% is the answer. All right, let's do some percent change. Percent change. Definitely one of the hardest things we do in this class and one of the most important. All right. So I'm going to give you an equation first, and then we'll work on some. So percent change, this is something you need to write in your notes. Percent change, let me rewrite that. If I say that's so important, I should do it a little more neatly for you all. This is something you need to write in your notes. Percent change equals the new value minus the old value over the old times 100%. That is very, very important, and it's something you need to learn. So a negative percent change, negative percent change means less. Positive percent change means more. Just something to remember as we do negative and positive signs. So let's work this out. Let's do the percent change. I'll write the problem. Percent change from 200 to 500. All right. So when I do percent change problems, I like to write out what's my new. My new is 500. What's my old? It's 200. All right. So let's say percent change equals new minus old divided by old times 100%. Well, 500 minus 200 is 300. 300 over 200 times 100%. 100%. All right. Now we have to divide them out. 300, 200, sorry, other way around. 200 goes into 300 once, 200, remainder 100. Decimal, bring down to 0. 200 goes in 1,000 5 times. There is no remainder there. Oh, someone said the board went all wide. If your board went all wide, I'd recommend there's a button in the bottom usually where you can like zoom out to everything and then come to the bottom where I am. If not, I'd recommend honestly leaving the zoom and then coming back in. So the decimal point there. So we get 1.5 times 100%. Now, when we want to multiply something by 100%, we need to take it and move the decimal place 2 places, 1, 2, and then add a percent. So the answer is 150%. So we got 150% bigger. Now I want you to try one. Tell me about the percent change from 20. Oh. All right, for this one, I want you to tell me the percent change, 25 to 45. I want you all to try working this out. So I want you to tell me what is the new, what is the old, and then remember, here's the formula, percent change equals new minus old over old times 100%. All right, everyone have a go at that one. Yeah, you can do. All right, so why don't you all give that a try? Here's a hint for you as you're setting it up. The new one is 45, the old one is 25. All right. We just learned a new formula type, Jose, for percent change. How are we doing? All right, I can give it another minute and then I'll work it, okay? All right, I'm gonna work it for you all. So percent change, the new one minus the old one over the old one times 100%. All right, what is 45 minus 25? That's 20 over 25 times 100%. Let's do the division out. 25, 20. We're gonna have to add a decimal to 0. How many times does 25 go into 200? It goes 8 times. So 0.8 times 100%. Now to go to a percentage, we have the 8. We go 1, 2. We add a percentage and we get 80%. I'm going to work a word problem out like this. All right. All right, there were 27 students in the class. Some dropped out and then only 18 were left. What is the percent change in the number of students in the class? Well, we've got to do it like this. We've got to say the new is 18. The old is 27. So now we use our formula. We say new minus old over old times 100%. The very ugly 0. Sorry, that 0 is ugly. It's mama doesn't love it. All right, 18 minus 27 is -9, and it's important to remember that it's negative here. Then, so we've got -9 over 27. We're going to do that math. $20 goes into 90 4 times. Bring down a 0. 20 goes into 100 5 times. So if we bring up the decimal and we've got to bring in the negative, we have -0.45 times 100%. Oh, sorry, I divided into, sorry, I messed that up because I did, this is an important thing why it's important to check your work. I did not copy the problem correctly. Let's start that over. it is 27 out here and -9 in here. So how many times does 27 go into 90? See, 27 goes 3 times. 27 times 3 is 81. Remainder 9. Bring down a 0. 27 goes into 90 3 times. So 90. Or actually 81. 9, 0. So this is going to go on forever and ever and ever. So we can just put a like that on it. So net, and remember it's negative point, negative 0.3333 keeps going times 100%. So we just need to go 1, 2. So we have negative 33.33% for our answer. All right, so now it's 8 o'clock. We have 30 minutes left. We've got 3 more topics to go over, but they're not nearly as complicated as percentages. I think percentages are the hardest thing. I'm going to give you a bit of a break for a second. I'm going to get a glass of water. I'm going to give you like a 1-minute break. I'll pause the recording just to give a little brain break. All right, we're going to talk about something called a factorial. And a factorial is a number with an exclamation mark after it. And what it means is you multiply all the numbers that come before that number up. So, and then just get the number. So I'm doing some examples right here. So 2 factorial is 1 times 2. 3 factorial is 1 times 2 times 3 is 6. 4 factorial is 1 times 2 times 3 times 4 equals 24. Why don't you try to do 5 factorial? Just write it out. Like, don't even have to come up with the math, like the actual number. Just write out the multiplication. What do you think it is based on this pattern? Anyone give me an answer what they think.
1 times 2 times 3 times 4 times 5.
Yep, that's right. So 1 times 2 times 3 times 4 times 5. And that's going to equal 120. You can say 24 times 5. All right. Now I want somebody to come up with the answer to 6 factorial for me. I just wrote it out like that. All right, I got one answer for 720. Yep, I got 2 answers. Yeah, that is the answer. Good. See, these aren't that complicated in terms of like what's going on there. Now I want to show you a trick with how they can be divided. Now, what if I give you like 6 factorial divided by 3 factorial? Well, that would be kind of complicated to write out 720 divided by 6. That wouldn't actually be that hard. But one way you can do it that makes it easier than having to do that, and we'll do a big one in a minute for practice that shows why this is helpful, is you can write them out 1 times 2 times 3 times 4 times 5 times 6, 1 times 2 times 3. In a division, when things are just getting multiplied, you can cancel the top and bottom. So you can cancel the 1 on the top and bottom, cancel the 2 on the top and bottom, cancel the 3 on the top and bottom. So all you have left is 4 times 5 times 6. So all that is 4 times 5 is 20 times 6 equals 120. Now, why don't you all try this one? How about this one? 9 factorial divided by 7 factorial. Why don't you all try that one? the first thing you're gonna want to do is write it out. And then you'll start canceling things out. So why don't you all give that one a try? All right, we've got lots of answers coming in. All right, great. So let's try this out. So you could do the long thing, figure out 9 factorial. That's a huge number. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. And then you can cancel like that. And you get 8 times 9 equals 72. You get 72. So good job, those who got that. Now I've got another one for you to work. This one's not as interesting. Now try 4. Oh, that happens sometimes. Got to erase that now. Now try 4 factorial plus 7 factorial. So now give that one a try.
Will the same method that you just showed us work or no?
Nope. This one you just have to do the math out. You can't cancel anything for this, for the addition like that. All right. All right, have a good night. Someone just told me in the private chat they had to be leaving. All right, we got all kinds of answers coming in. All right. So 1 times 2 times 3 times 4. 4 factorial is just 24. 7 factorial, 1 times 2 times 3 times 4 times 5 times 6 times 7. Well, if you remember 6 factorial equals 720. So we can say 7 times 720 is 4,940. Then we can say 4,940 plus 24 is 4964. That looks different than what everyone else got, so let me make sure I did the right thing. No, I didn't. That should be 5,040 there. So if that's 5,040, that means it's 5,064. Look, you all did better than me. I had to check my work on yours. Good job. All right. Gonna go to another topic now called FOIL. And now factorials, honestly, I hope you feel pretty good about it. I don't think it's the most complicated thing we do. I think it's the kind of thing, if you practice it a little bit this week and then review it a little bit before the ASVAB, any factorial problems you see, I think you'll get right away. So let's look at FOIL. So sometimes we need to multiply what are called binomials. And a binomial is a problem like this, or two math things like this. X plus 1, x plus 2. And FOIL stands for something. It stands for first, outside, inside, last. And that's the order we multiply things in. We've got to go first. X times x is x squared. This is why we learned those exponent rules a while back. Outside, x times 2 is 2x. Inside, x times 1 is x. And finally, last, x 2 times 1 is 2. All right. So we have x squared plus 3x plus 2 is our answer. Let's do another one. I'll do x minus 2, x plus 5. And now something I'll show you on this one. So first, x times x is x squared. Outside, x times 5 is 5x. Now on this inside, negative 2 times x is minus 2x, not plus 2x. And then negative 2 times 5 is minus 10. So now it's x squared plus 3x, because we have 5 minus 2 minus 10 is our answer. Now, something I want you to notice is if you do the FOIL neatly, first, outside, inside, last, it looks like a smiley face. See? Looks like a smiley face. So that's another way you can remember it. You're making a smiley face. Now that one's so goofy looking, you gotta erase it. That's a way you can remember the FOIL. Remember FOIL. So I'm gonna have you all try a problem. X plus 2, x plus 3. All right, so I want you all to try this one, okay? All right, I got one answer in. I'd like to get a few before I try it, but if no one comes in a little bit, I'll do some. All right, yeah, get your pizza, Steed. All right, I've got several answers now. Let's do this one. First, x squared, outside 3x, inside 2x, last 6. So we get x squared plus 5x plus 6. That's okay. Somebody's upset they forgot to do the last one. You forgot to last. Good job. I got a right answer in the chat, so good job. All right, let's do this next one. X minus 1, x plus 1. So now we're adding a negative. So now here's one for you all to try. Okay, I got an answer in. Let's see if we can get some more in real quick. And I got 2 answers in. I'll give it a little bit longer. All right. We're going to go first. X times x is x squared. We're going to go outside. Plus x. We're going to go inside. Minus x. We're going to go out last. Oh, last. And -1 times 1 is -1. So we have x squared minus 1. These cancel each other out in the middle. Now I'm going to work 2 more. I'm going to work 3x plus 2. And then 4x minus 2. First, now we have additional, we have numbers in front of the variable, so that's harder. We have 12x squared, outside minus 6x, inside plus 8x, and then last minus 4. Excuse me. So we have 12x squared plus 2x minus 4. There's an answer. Let's do this one. 3x minus 3, x minus 2. Let me make sure I wrote that correctly. All right. 3x times x is 3x squared, outside minus 6x, inside minus 3x, and last plus 6. Now we have to bring those together, minus 9x plus 6. So now I've got one that's more complicated like this for you. 2x plus 2 and 3x plus 5. All right. Why don't you all give this one a try? All right, I've got some answers coming in. I like it when answers come in. All right. Six x squared. One of you, I don't out you when you do the private messages, but some of them crack me up. Thank you for making me laugh. 2x plus 5 is 10x. 2x times 5 is 10x. Inside, 2 times 3x is 6x. Last, 2 times 5 is 10. Add everything together, 6x squared plus 4, sorry, not 4. I don't know why I was trying to subtract. 10x plus 6x is 16x plus 10. Somebody's sending me a message asking about the answer. The person saying 6x minus 3x equals 3x. I'm not sure what you're saying. Which problem you're talking about. So this is the answer for this one. I've got another one for you to work. 4x minus 2. All right, the other equation, I'll go back and look at it when we get this one on now. 4x minus 2. Oh. 3x plus 3. Man, look at it. All right, I got some answers coming in. All right, I think I got plenty of answers in. Let's work this one. 4x times 3x is 12x squared. Outside plus 12x. Inside, inside, minus 6x. Last minus 6. Sorry, not x, minus 6. So we have 12x squared plus 6x minus 6. I don't know why it just stopped writing it. It's being weird. Minus 6. And sometimes I start writing an angle. I don't know why I did that. Here's kind of the last type of problem we're going to do. X cubed plus 1 times x plus 7. So now when we do this one, this becomes x to the 4th plus 7x cubed inside. I don't know why it's doing that. Plus x outside plus 7. So for this one, I'm gonna fix that line. For this one, it cannot be simplified any more than it is. So this is the answer. So now why don't you try x cubed plus 3 times x cubed plus 2. This is a tough one. All right. Yeah, it's lagging. I don't know why, but there you go. Try this one. All right, at 8:29, I'll work this problem. All right, 15 seconds. Got some answers coming in. I love that, love that, love that. All right, gonna work it. So we go first. X cubed times x cubed is x to the 6th because you add the exponents when you're multiplying them. Outside plus 2x cubed, no problem. Someone said to leave early. We're done in a minute. Plus 3x cubed. Last plus 6. So now we have x to the 6th plus 5x cubed plus 6, and that's our answer. All right, there are 15 seconds left in the class. Thank you all for coming. If you have any questions, feel free to 2 times 3 is 6 is why it's 6. Someone asked. If you have any questions, feel free to stay in. Oh, I see. Someone wants to know what x to the 6th. So if you have exponent, so like x cubed times x cubed, when you do this, if it has the same base, you add the exponents. So you add the 3 and the 3. That's why when we have x times x, it equals x squared, because there's an imaginary, not imaginary, there is a 1 there. It's just, it's not written. All right, so if anyone has any questions, feel free to stay on. We can work some more. Thanks for coming, everyone. This is a really good session.
I do have a question.
Sure, yeah.
You said 3x squared minus 6x minus 3x plus 6 is 3x squared minus 9x plus 6. How is it 9 and not 3?
Okay, I see. So let's write this. 3x squared minus 6x minus 3x minus 3, or was it minus 6 at the end? It was plus 6. Yeah, it was plus 6.
Yeah.
Let me fix that. All right. So the deal with this is that we have two negative numbers here. So when you bring negative numbers together, when you bring negative numbers together, they get more negative. Now, so imagine if you had one bank account, Alaya, and then this bank account you had negative $10, and then the other bank account you had negative $20. How much money do you have in both bank accounts together?
Broke.
Yeah, broke is the answer. Someone asked for the YouTube channel. Let me send it real quick. You have negative 30. You
Are you
have
still recording?
negative 30. Oh, yeah. Sorry, I need to stop recording. Thank you.